My name is Aleh Hishchuk. I am in charge of operations here at SDC Verifier. We are partner of Saratech, and today I'm going to speak about how to save time validating your models according to rules and regulations with the help of the FEA and SDC Verifier software. Very brief agenda of what we're going to look through today. So I'll start with the introduction of the workflow. I will speak about the load and combinations. So basically, after workflow introduction, I will start addressing different questions and issues that are actually appearing along the verification and validation process, and that are actually helpful, that are actually extremely important to in the validation process, and that will help to save your time. So it is combinations of loads, it is the recognition and detection of the structural members, it is the checks itself, so how to automate the checks and make it quick, reliable, and for a complete model. It is reporting, of course, nobody likes doing repetitive routine work with documentation, and design optimization that saves a ton of time in the later stages of the project. And in the end, we'll have some conclusions. So this is the diagram that displays the workflow within SDC Verifier. And this diagram helps to understand what stages the engineer would have to go through and where we can save time, what problems might occur along the verification according to rules and regulations. So we'll speak about FEA today. The products that we are able to use for the validation of our models are Femap, Simcenter Femap, and Simcenter 3D. Great FEA software that allows us to build our models, to generate the finite element mesh, to apply the loading conditions, analyze it, and receive a certain outputs like forces, stresses, displacements, strains, and so on, which help us a lot to understand the behavior of the structure, to understand the stresses, but it doesn't answer the question, is my model okay or not okay according to rules and regulations? And there are plenty of standards that are describing a certain failure modes and helping to assure that your model is actually okay in terms of beam buckling, plate buckling, stability, fatigue, static stress checks, bolted connections, welded connections, and so on. So we have documents like AISC or API, ISO, Bureau codes, the common in Europe, DNVGL in the for the offshore industry. So multiple countries or regulatory bodies are providing the documents that helps us to perform the checks according to rules and regulations. But these checks are extensive, and these checks are well, it is possible to do it by hand, but it is extremely time consuming and the room for error is huge. So certain pre and post processing actions should be performed to verify your model against these rules and regulations. So at the very first stage, the model is built and prepared within Femap or Simcenter 3D interface. Next, well, the first issue would be the combination of loads and combinations in accordance with the standard, because the structure is usually subjected to huge amount of loads and they should be combined in a certain way, which is possible to automate. Next item is structural recognition, because your model within Femap or Simcenter is a big amount of finite elements, thousands or millions of finite elements. But checks are done not on finite elements, but on structural members. So you need to know structural members out of your finite element model to perform the checks. Then the huge room for automation is the possibility to make the checks themselves. Last but not least is automatic documentation, which helps to prepare the template-based report according to a certain rule. And On the final design stage, of course, your results might not always be satisfying for the customer or the end user. So you would have to optimize your design to comply with the rules and regulations. So optimization of the design and avoiding routine guessing of the correct design for proper evaluation is mandatory and extremely important. So the examples and the actions I'm going to demonstrate to you today are applicable to multiple industries, not only limited to those I'm showing now on the screen, but these are the main one, in my opinion. So highly regulated industries, where to build and to put the structure into operation, you have to comply with a certain set of rules. So oil and gas, offshore and maritime, heavy lifting, machinery, aerospace, renewable energy, civil engineering, basically any industry where structural design is involved and a certain failure mode check has to be performed. In every of these industries, it is important to perform the simulation and to validate the results of the simulations according to design standards. So as I just mentioned with the workflow diagram, there are 5 more questions, 5 more main struggles that we are going to solve with the help of SDC Verifier for your FEA model. So let's start with the load combinations. In case of performing the load combination, the standard is usually coming up with the table like this, where you have a matrix of different influences. So you have regular loads, occasional loads, exceptional loads that has to be built into combinations with taking into account partial factors, safety factors, amplification coefficients, dynamic factors in some cases. So your whatever structure you design is subjected to multiple loads, and standards are prescribing these loads to be combined in a certain way. We have a nice interface that allows to build a matrix of loading, and this interface allows to prepare to take into account all possible scenarios to simulate the behavior of your structure. And not only that, this interface also allows to save calculation time. So since we're speaking about the time-saving benefits, it allows to save the calculation time with repetitive loads, with loads that are having a changing magnitude, which loads that are having different values. So this is the calculation core that is presented, and it consists of 3 main elements: individual loads, load sets, and load groups. So what are those items? Individual loads are single load results, are individual influences on your model, and individual load is usually a combination of FEM load, sorry about my handwriting, and constraint. So that's the single influence. These influences could be linearly combined into loading sets, what you've just seen on the matrix. And within these loading sets, individual loads could be multiplied with factors and coefficients. So this allows you to set up a unit load for whatever, let's assume this middle bridge load here is having, you're not sure about the value, so you can just apply 1 kilonewton or 1,000 pounds of a force to a certain location, and then multiply it with any factor you would like to have, because within the loading combinations you're able to linearly combine them into sets. I'm often getting a question: what is going to happen if I will be in need of making the nonlinear calculation? It's not a problem, because loading sets can be exported back to solver, to Femap, to be solved as individual loads. So individual load is a single action. Load set is a linear combination of loads which help you to simulate different behaviors. And then the load group, the third item, is the envelope set of result. Load group allows you to build, to present the absolute values or minimums or maximums of everything what is included within the group. So you can make a loading group of load sets, you can make a load group of individual loads, or even make group of groups. This is the best tool for presenting the results. So you can have every action of your structure, like weight, operational condition, wind loads, wave loads, environmental conditions, as a single influence, then combine them into ultimate limit states or operating conditions, and then make a group of all possible operating conditions for the reporting purposes. So the calculation core of building the matrix and using individual loads, load sets, and load groups helps you to save time on presenting the results according to different standards and to do the checks within all possible scenarios. Also, what is extremely important, it also helps you to save time on solving the model. So you can avoid creating multiple loads. You can just use factors for multiplying. Besides combining the loads in accordance with a standard, SDC Verifier also has features to apply specific loads directly in the interface of Femap or Simcenter 3D. So loads that are not that easy to apply from scratch are automated within SDC Verifier software. For example, it is possible to apply a distributed pressure of wind load, or hydrostatic pressure of wave load, or the tank load to by determining the height or the density of material in that tank. And it all comes with a nice and user-friendly interfaces where you have to determine the vertical direction in your model, direction of the wind or wave, portion of model subjected to that load, and a certain group of parameters like pressure over height or wave settings. And then within clicking one button, SDC Verifier takes care of applying this complicated loads. It's also possible to apply multinodal force based on selections, just to save time on routine clicking of certain locations where you would have to apply your loads. So we just covered the loading combinations. Next part is recognition of structural items. As I just said, your FEA model is the big bunch of finite elements, and what you would need to do is to determine the structural members out of these finite elements. So SDC Verifier is capable of recognizing multiple different structural members like joints, beam members, welds, plate fields, stiffeners, and so on. All these members are used for certain groups of checks. For example, joints are determined within one click of a button, and they are used to for the joint checks and connection checks according to multiple standards, so to determine the complete capacity of the joints, or they're also used to calculate and to check the buckling lengths, because the next recognition is recognition of beam members. So your FEA model might be consisting of multiple members from connection to connection. Like in this case, we have about 10 to 15 members over the length, finite elements, sorry, over the length of this beam. But for checks of the buckling and stability of these members, we need to have the effective lengths, and we need to take into account the type of connection. So SDC Verifier automatically detects the connections and then determines the lengths, effective lengths, considering type of connection. So as you can see, we have a small connection over a weak axis of the beam here, which splits the member into two submembers of 3 meter long for length Y, and it is a 6 meter long member for the length in the strong axis direction of the I-beam. So what I'm trying to present with this is that you build your model within the FEA as a list of significant amount of finite elements, but after the recognition, which is basically 2 clicks, after the recognition is done, Software is capable to determine your model as a list of joints, connections, and structural members. So summarize the forces or stresses or determining certain parameters for these members to perform the checks according to regulations. And the time-saving benefit here is obvious. It's a one click of a button to determine them all. And for 1 million finite elements model, it takes about a minute to determine all the structural members within that model. The same can be done for plates. Extremely helpful for shipbuilding industry, but basically for every industry where any type of checks where the structure is subjected to plate buckling, it is extremely important to determine the plates, the dimensions and parameters, to summarize the stresses over those plates, and to be able to run it through the plate buckling checks. So once again, it is completely mesh independent. You can have we have let's say this plate, which is 2 by 4 elements, the yellow one, but it can be 200 by 400 finite elements, and SDC Verifier still treats it as one plate for plate buckling checks. And again, not only for shipbuilding, aerospace industry, or any kind of machinery where plate buckling might be a problem, is this recognition is extremely important. And the same goes on for stiffeners. So if you need to perform, or when you need to perform the stiffener buckling check, automatic recognition of all the stiffeners within a certain panel is available within just one click of a button. So here's the picture of the interface of Finder tool. All you have to do in this case is press find, and SDC Verifier automatically comes up with the list of structural members in your model, in this case stiffeners, for further stiffener buckling checks. Important, I would say one of the most important group of checks are weld strengths and fatigue. Fatigue is most likely to occur on welds, so you need to have a way of determining the welds. And SDC Verifier is providing this way of determining the welds in Femap models by, again, clicking just one button. All the connections of property change, material change, thickness change, or shared nodes within two planes with a certain angle will be determined as welds. And it's not only detecting the welds and the elements that are subjected to be the welds, but the software is also updating the stresses and the forces in the weld direction. So after the recognition is done, the force along the weld and perpendicular to the weld is available and can be used for determining the classification of the weld or to perform the checks according to regulations. This is the interface of the weld finder. So basically, you have a model which is just a list of finite element. This is the interface of the tool, where the only thing you have to do, as I just said, is to press find. Software is automatically evaluating your model and providing you with the list of parameters that has to be with the list of checks. If there is also some, if there is a need of adjusting the quality of your mesh. So it's not only determining the welds, it's also defining it's also finding errors in terms of mesh connectivity or free edges or nodes that are impossible to recognize. And after that, the software treats your model like this, like a list of welds that are available and that are open to perform the weld strengths, to set up the classification for weld strengths and fatigue and run the checks according to rules and regulations. Groups of exceptions are available. So if you, for example, have a rolled beam, it is possible to set up an exception that between property 18 and 19, there is no weld. So that exception will be taken into account and software will skip the connection in this case. So that is in terms of the load combinations and recognition. And the next big group of and the next big item in the process is the checks themselves. The software uses the parameters of your FEA model and the results of your outputs of your analysis as variables to perform the verification. So basically, it is possible to use your FEA model to do an automatic verification according to multiple rules and regulations. It consists of plate buckling checks, as I just said, beam buckling, stiffener buckling, weld strengths, fatigue, joints and connection checks, bolt checks, and multiple other checks. The thing is that the interface is completely open, and it's a simple interface which allows you to either use predefined formulas from our library or write your own, where you use, as I said, the parameters of your model or parameters of your material or outputs of the calculation like stresses or forces to as variables of writing formulas. And if you can write formulas in Excel, that's basically pretty much similar logic, which allows you to build these checks. And you can build any type of checks you can imagine. So basically, whatever you want is available here. You can do simple yield checks, but you can also do, I don't know, price per weld calculation, and whatever you can imagine. There is basically no limits. And afterwards, the results are presented in a convenient way with plots and tables. So it's possible to use the graphical interface of Femap to build the nice picture with the results, or it is possible to build different types of tables over the results, over selections, highlighting the values that are not according to the standards. It is also possible to set up, as I mentioned, set up classifications for fatigue checks, to assign a proper essence curves, and to be able to run the fatigue checks on each and every weld of your model. The same applies for the weld strengths. Setting up the class of the weld, the type of the weld, is it single fillet, double fillet, full penetration, the size of the weld, and then run the checks through each and every weld, receiving the complete calculation details and nice picture with the results of the evaluation of all of your welds. Hotspot stress method for fatigue is also available, so software is capable of assigning a certain reference points formula for every weld in your model and automatically evaluating the hotspot stress to be used for fatigue checks, for example. Bolt checks. If your model is built within, if you have a bolted connections where every bolt is modeled as a beam element, it is possible to determine the axial force, shear force, slip resistance, and highlight which bolt in your connection is going to fail first, or prevent this, of course. Complete calculation details are available for each and every calculation. So basically, if you want to present the results to someone, or if you want to go through the calculation and see where the problems might appear, it is possible to have this. It is possible to have basically like a hand calculation, but once again, for your complete Femap or Simcenter 3D model, under hundreds or thousands of loading conditions, so multiple loads are available. And of course, all the checks are automated, so when you are creating a certain standard document, you just have to define a couple of options which are fit into a nice user-friendly interface, press OK, and represent your results. So what is the time benefit here? You can, because somebody can say, okay, I can do a check according to regulation by hand, but calculating by hand, you can do a one structural member under one loading condition at a time. SDC Verifier allows to verify your complete model within the under the multiple loading conditions and store this calculation procedure to be used with different models for the future. And by storing the procedure and results, there is another thing: automatic documentation. Nobody likes to do reports. It is quite boring and repetitive routine. So we have come up with the tools to perform automatic template-based documentation, which will not only describe the results of your analysis, but which will also describe the calculation procedure. So how your model is built, what are the property used, materials used, parameters, loading combinations. It's all included in the chapter which we called model setup. So here you can see an example of it. And then all the results of your analysis built with nice colored plots and tables explaining each and every combination. They are included in template-based structure. So you describe how your model is built, you describe all the result, and you follow the same structure for multiple conditions, for multiple loads, and for the complete scenario. And the biggest benefit here is if your model has changed, the only thing you would have to do is go to Femap, recalculate the model, and generate new report again. So the interface of the report designer looks basically like this. You build the structure of your report, you press generate, export to Word, and you have a new document. And if something has changed in your model or calculation scheme, you just go back to Femap, run the analysis once again, and generate a new report with updated results. This saves up to 40% of time on verification in terms of the results presentation. So we covered report, and last but certainly one of the most important ones is the automatic optimization tool. So optimization allows you to pick the best possible design decision based on results. So let's assume we've gone through all the previous steps, the combinations, recognition, checks, and report, but our structure is not built according to this requirement. So what would we have to do then? We need to pick the possible replacements. And of course, we can guess them, recalculate everything again, see what's going to be there. But we can run an automatic tool which will pick a certain locations that are not passing the requirements. Then we connect it with the possible replacements from a library of cross sections, if in case of beams, or with possible replacements of thicknesses for plate buckling, or cross sections for stiffener buckling, or possible replacements of a weld type. So let's say we've done partial penetration weld of 2 millimeters or 4 millimeters, but we can also try the full penetration welds and so on. And the software will automatically calculate the certain standard that has been assigned and optimize your design based on the parameter by defining the optimal value of either a cross-section area or thickness or weld type to comply with the requirements of regulations. So basically there is no more guessing and no more unknown estimation for picking up the best possible design decision. You don't need to guess, you just define the possible allowable or allowed replacements and make the software, go make yourself a coffee and make the software do the job, automate the checks and do the checks with possible replacements multiple times to pick the best design decision based on the requirements of the code. And to sum up this, we went through the calculation procedure and the most time-consuming tasks in the evaluation of any FEA model according to certain set of rules or regulations. So within SDC Verifier with your Femap or Simcenter model, you're able to perform code checks directly in Femap and Simcenter according to multiple popular standards. The standards are open, can be customized, and you can write your own checks. The complete calculation procedure is saved. We have extensive reporting, which allows to build template-based documents, and a huge time saver in terms of design optimization. One of the feedback that explains that, this is the slide I received of one of our customers, Allseas in the Netherlands. They operate one of the biggest vessels in the world that is used for installation of offshore structures, installation or retrieval, decommissioning, and they build multiple loading conditions for multiple models, generate a lot of reports for yield and buckling checks. And they generate thousands of pages of results in 2 days, so completely automated, which is saving them weeks of, well, maybe even months of time on this operational analysis of the installation process. And there are more. There are plenty of engineering companies, design companies, operators of equipment, designer of equipment who use the software around the world. And not only the engineering companies, but also certification societies like Bureau Veritas are benefiting from using SDC Verifier within FEA programs. We will, of course, share with you a lot of materials about how to use that, and a lot more materials are available within SDC Verifier software. You can find more information on Saratech website as well. We have a YouTube channel which provides with tons of good information that helps you to set up a calculation procedure or perform a certain action. And we are, of course, more than happy to provide the training or educational session, either online or within your office.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.